Earlier we discussed the idea of sequences and we looked at a bit of their notation, and in the next two sections we're going to talk about particular types of sequences. First up is the idea of an arithmetic sequence. So what is an arithmetic sequence? An arithmetic sequence is a sequence where the difference between any two consecutive terms is constant. It's the idea that you go from term to term by adding a constant value. And the constant value that we're adding is called the common difference, often expressed as a d. And since this formula is so intuitive, we have a nice formula to represent that. So to find any nth term in the sequence, all you would do is you would say, let's start at the first term, and then since we're at the nth term, we've moved over n minus 1 times. Each one of those moves, you add the common difference d. We know repeated addition is the same as multiplication, so we add the term n minus 1 times d. Now let's see if the following sequences are arithmetic. We know arithmetic means term to term there's a common difference from one to the other. So looking here, if we were going 1 to 2, if there was a common difference it would be 1, right? Because 2 minus 1 is 1. Let's see if that holds up. To get to the next term we'd expect it to be 3 then, but it's not, it's 4. So this is not a common difference, because from here d would be 1, but then next d would have to be 2, up there d would have to be 4, d would have to be 6, and that's not arithmetic. It needs to be a common difference each time. Take a moment to investigate the behavior of the next sequence described in Part B. How do we get from -3 to 1? We add 4. Let's see if this behavior is consistent. How do you get from 1 to 5? You also add 4. It's holding up so far. From 5 to 9, you also add 4. 9 to 13, you also add 4. So of all the terms that we see pictured, you're adding a constant term of 4. That tells us that this is an arithmetic sequence, and the common difference is 4. Now sometimes we're told what the common difference is, and by giving this piece of information, this is just an indirect way of the problem telling us that we're dealing with an arithmetic sequence. And we're asked to write the first 5 terms. They tell us that we're starting at 17, and every term we subtract 3. So the first term was given. For our arithmetic sequence, there's the common difference, so it's going to be 17 plus the common difference, but in this case, adding a negative is the same as just subtracting 3. So our second term is 14. We would expect the next term to be 3 less, which would give us 11. The next term would be 3 less than that, which would give us 8. And the next term would be 3 less than that, which would give us 5. And if we wanted to, we could even write a formula for this. We know the formula for an arithmetic sequence. If you want to find the nth term, you always start at the first term, and then you add n minus 1 times the common difference. So in our case, the nth term is going to be equal to 17 plus n minus 1 times our common difference of -3. And the benefit of having this formula is here we kind of did a recursive approach. We just kept subtracting 3 to get the next term. But now that we have the formula, we could easily find something like a sub 10. It would be 17 plus 10 minus 1 times -3. Which would be 17 minus 27, and that would give us the value -10. Next, we're asked to write an explicit formula for the arithmetic sequence 2, 12, 22, 32, 42. We know the formula is of this form. So what do we need to fill in the formula? Well, we need to know the common difference, and we need to know the first term. Now the first term is easily spotted right there from the sequence, and we can also find the common difference. Let's think. From 2 to 12, we added 10. Let's see if that holds. 12 plus 10 is 22, holding so far. 22 plus 10 is 32. 32 plus 10 is 42. So that tells me that the common difference is 10. Now that we have those two pieces of information, then the formula is just 2 plus n minus 1 times 10. Now remember that arithmetic sequences are very well understood. They have that common difference. We know a general form of their formula. So because of that, even if we're just given a few terms in the arithmetic sequence, we can find a generalized formula for the whole sequence and then find any term we want after that. So given that the first term is 8, the fourth term is 14, we need to find the fifth term. And let's make it clear also that this is an arithmetic sequence. It's assumed from the section we are in, but we would need to be told that. Now there's a few ways you could go about this. We know that we start at the first term 8, and then we go to the second term, then we go to the third term. Finally at the fourth term we're at 14, and then we want to find the fifth term. So one of the things that you could do is you could say, since you added a common difference, 8 plus something plus that same something plus the same something again would give me 14. So you could say I had to start with 8 plus the common difference to get to the second term, plus the common difference again to get to the third term, plus the common difference again to get me to the 14th term. So 8 plus the common difference gives you the second term, plus the common difference again gives you the third term, plus the common difference again gives us the fourth term, 14. Now this formula could be simplified to 8 plus 3d equals 14. We can solve for what d is. We'd subtract 8 from both sides, and we would get 6. Divide both sides by 3, and we get the common difference is 2. Now let's make sure this works. So 8 plus 2 would give me 10. 10 plus 2 would give me 12. 12 plus 2 would give me 14, so it works out. If you add 2 each time, you will get to 14 by the third term, or fourth term. So then what should the fifth term be? It should just be 14 plus 2, or 16. And that could be one way that we go about this problem. So that's our answer. That's all we'd have to do. I'm going to illustrate another method though if you prefer. Another method is to just work with the formula. A sub n equals the first term plus n minus 1 times the common difference. Now right now there is 1, 2, 3, 4 things that we don't know. But we know if we could substitute in values, if you ever get down to an equation in one variable, you can solve that. So for instance, we know the first term is 8. So let's simplify that. And this is actually a key piece of information. When n is 4, a sub n is 14. So when n takes on the value 4, and you multiply it by, subtract 1, multiply that by the common difference, add 8, the resulting value is 14. And now do we see we have an equation in one variable, so I can solve for d. So we would get 14 equals 8 plus 3d, which you see is exactly the equation we got here, just from a different method. And then we solve it, and eventually we would get subtract 8, divide by 3, d equals 2. Once we have that d equals 2, we substitute that into our equation, and we would get a sub n is 8 plus n minus 1 times 2. So we can quickly find the fifth term, 8 plus 5 minus 1 times 2, or 8 plus 4 times 2, or 8 plus 8 gives us 16. So this is using the formula step by step, substituting in our known values, isolating for the unknown. And then this one is particularly thinking about, okay, where are we starting? What's our next piece of information? We know that there had to be a constant term each time. So we can set up this equation that we can then solve to get our value and find the next term. So just to recap all of this, remember if you're told something's an arithmetic sequence, that's giving you a lot of information. That means each term, to get to the next one, you add some constant value. We know the generalized formula for an arithmetic sequence is always the first term plus n minus 1 times the common difference.